All right, welcome everyone. This is week 4 of backend development with Python and MySQL. My name is Mildred. I will be your instructor for this course. Today we are going to go back and recap all we've done so far and look at how to modify data in MySQL. We're going to still stick to the basics until we get to week 5, where we are sure that everybody now gets an understanding of basic MySQL queries before we start going deeper into more complex examples. Today I'll be working with a different database called the Classic Models. If you want to download that, you can go to this website, mysqltutorial.org, and click on download MySQL sample database to get the Classic Model database. And I'm doing this so that we can see a variety of different examples and we're not just on the secular database. So if you download this example, you unzip the file, come to your MySQL Workbench, or if you're using PHPMyAdmin, you go to your SQL tab and run the queries in the file, copy and paste, just like we described in week 2. Okay. So in the Classic Model database, we have the customers table, the employees table, offices table, order details table, orders table, payments table, product lines table, and products table. And we're going to be working with these tables to illustrate further examples. Now, at the beginning of the course, when we introduced the course, we looked at basic queries that we can use. We say if we want to select a database to use, we use the query use and the name of the database, let's say Classic Models. And then when you run this, it selects the schema or the database that you want to use. So you want to always have this statement as the first statement on your file to select the database that you are going to be using. If we have the database selected and we want to see all the tables in the database, we use the query show tables like this. And then when we run this, it shows all of the tables in the database like that. If we want to select, let's say, all the columns from a particular database table, let's say we want to select all the columns from the customers database table, we say select all, indicated by an asterisk sign from the name of the table, customers, like that. And we get all of them, all the information on the table. So we have the columns and the rows of different data. If we want to select just specific columns and not all the columns from that table, we can say we want, for instance, select the customer number and the name and the city and the country. We do select and we specify the column names as a comma separated list. So by convention, you just want to write this in uppercase. SQL keywords is not case sensitive, so even if you write it in lowercase or in any case, it is still going to run correctly. So we'll say select customer name, which is or customer number first, which is the name of a column, customer name, which is another column we want. We want to know also the city that the customer is from and the country where the city is from. And all of this we want to select from the customers table. And so we get just those columns that we have specified. Okay. If we want to specify information across multiple tables, this is where we begin to use joins. Joins is not difficult, but it's easily confusing. And so let's try using joins on this database and across the tables here, so we can see. We're going to use more complex joins when we get to part 3, but we are doing as basic as possible for you to get an understanding of this so as not to get overwhelmed. And as we go deeper week by week, we use more complex examples. So let's say we want to select information from the customer table, and let's see the payments table. Now the payments table has the customer number, the check number, payments date, and the amount paid. And the customer table has the customer number. So customer number and is common on both tables. So we have a predicate, which is a common column for both tables that we want to join. You can join more than 2 tables. You can join 3, 4, 5 tables. What we want to get across this table is, let's say we want to get the amount of money paid by each customer, but we want to get just the amount from here and get the customer number and the customer name from the customers table. So we're going to use the join, and we're going to write the query like this. We use an alias, select a dot customer number. We want A to represent customers. So you can just go directly to say select customers to customer number. But when you start getting to complex queries, it's always better you use A, B, C to represent what the table is and later define what A is. So say select A from A dot customer number, A dot customer name, and then we have B dot amount. B is another table, so we're saying A is the customers table and B is the payments table. So we'll say B dot payment, and we're selecting from the first table. We're selecting A is customers, so from customers A. So now it knows that A refers to customers. We want to use inner join. Inner join, we want to join the payments table. So we'll say inner join payments, the name of the table, payments, and we'll say payment is B. So we'll say inner join payments B on the common predicate. So what is that common column that the customers table and the payments table have that will be able to link these two tables together? And we'll say the customer number is their common column. So we'll say on A dot customer number is equal to B dot customer number. So what we are saying here is give us a column called customer number, customer name, and the amount. The customer number and the customer name should be selected from the customers table, which we represent by A, and with the amount should be selected from the payments table, which we represent by B. But for it to know which of the customer to match with which amount, you should check the column customer number, which both of them have in common, to say where the customer number in the customers table is the same as the customer number in the payments table. Join those columns together, these three columns together, and bring it as one table. And when we say go, we have them: customer number, customer name, amount. So now we can see we have this customer has several amounts they paid. We can actually run another query to get the total amount from each customer instead of having several payments made by the same customer. So we want to see the total number or the total amount paid by a particular customer. This time we can use the different functions that we have in SQL. For us to run that, we can say select customer. Let's use the customer number. We want to select the amount. We are going to be doing this from the payments table, amount. But what we want for the amount is the sum. So let's use an aggregate function called sum. We want it to total the amount of each customer, and we want to use an alias. When it comes out, you should just write it as total. As total. So select customer number, sum amount has total. We're selecting this from the payments table, and we want to group this by the customer number, because we want all the customers with the same number, the same customers, to have their total amount calculated. So we are using the group by clause to group this. So the thing with the group by clause is you have to select the column that has multiple rows with the same number to group by. So because we have customer number appearing several times across different rows with different amounts for the same customer, we want to group all of that customer together as one and calculate the total amount when it presents. And so when we run this and all is well, we should get the customer number and the total amount that they spent, like this. So instead of having customer 103 appear 3 times, we just have their totals calculated for us once and for all. Okay. In the event we say we don't want to have all of the customers, we just want to see our top customers and see people who spent over 100,000 or 20,000, or we have things like that. We can now use another clause. Let's say select customer number. Let's use sum of the amount. As total from payment, and we want to still group by customer number. Now we're going to use the clause having to specify a condition for the grouping. So I want to say having this total that we're creating, let's say greater than, let's say 100,000, like this. So we don't want all of it. We just want to see the customers who have their total amount spent greater than 100,000. And when we say go, it filters out, and we only have few customers who have their payments or their totals greater than 100,000. So these are queries. These are not complex queries. They are basic queries that helps you to understand how we get into complexity. So if you watch the pre-recorded videos from weeks 1 to 3, you will get an insight or different examples of the same kind of queries. You'll see how to sort by ascending or descending order in your videos. So let's go to the topic of today. Or before that, someone asked that we refresh on subquery, which was a little confusing the last time. So I'm going to refresh the subquery here. Let's use a subquery to let's say we want to select all the customers where they're, let's look at the customers table to see what they actually have. Okay, let's say we want to select all the customers where the country is USA, right? And from that country of USA, we want to still run, get the total amount each customer spends, but only for customers that live in the US. So this will be a little more complex subquery. The first thing we want to do, or the inner query we want to have, is to first find out all the customer that lives in the US. I want to just get the customer number. So always start from, I prefer to always start from the inner query before I build the outer query to select from the inner query. And the inner query is we want to select all the customers who live in the US. So we'll say select customer number. And we're selecting this from customers. And we use a where clause to say where country, let's say country, is equal to USA. If we run this query, we're just going to get that select query. We have only the customer numbers of the customers that live in US. But this is not what we want. We want to use this query as an inner query. So I'll put it within brackets like this. And the outer query, what we want to do is to get all of the customer and the total amounts they spent, just like we did with the group by clause. And we want to get those who have spent above 100,000 but live in the US. So the inner query is to select all the customer that live in the US as the inner, so that it just selects the outer, or the outer from the inner. So I'll say select customer number. I'll still use the sum of the amount, and this will be doing this from the payments table. Has total from payment group by, we're going to be grouping by the customer number. Then we use the condition having total greater than 100,000, and then we use and. So we have the and the or. So and is we want the total number to be, the total amount spent to be greater than 100,000, and we also want the person to be living in the USA, and then the customer number in the result of this query. So let me go over the logic again. I want to get the total amount spent by customers where the total amount is greater than 100,000 and the customer lives in USA. Now this is going to happen across two tables. So to use the subquery, I first of all want to think about it in a different way, and there's a different way you can actually write this. You can think about it in a different way and get the same result. The first thing I want to think of is, let me select all the customers that live in the US first, and then run a query to calculate the amount spent by all of them that live in the USA. Selecting all the customers that live in USA is the inner query, which is this, where we make the subquery, and the outer query is to calculate the total amount spent by each customer when the total is greater than 100,000 and the customer number is found in the result of this query. And when I run and all is well, we're going to get just these rows returned, because these are the customers that live in the USA. So this is a recap of what we've done so far leading up until week 4. For week 4 content, we are supposed to discuss modifying data and transactions. I'm going to discuss modifying data today, and I'm going to leave transactions until week 6. And the reason is I want you to be able to have the time to watch the video uploaded today for transaction. It's a little bit complex. It's not as complex, but a little bit more difficult to understand. And when you've gone over the video and I begin to explain it in details, you will understand it better. And it's preferable to handle that topic closer to when you have an assignment on that topic. So we're going to look at how to insert new record into a table, how to update existing record, how to delete record from the table as today's new topic. Anybody has questions about the old topics before I move forward?
Yes, I have a question. Okay. Pretty straightforward. Is subquery, can subquery be seen as a type of join?
No, it's not a type of join, but you can actually use it to join tables and you can actually use it to do exactly what you use joins to do. But it depends on which is more complex for you. Sometimes you can have the same idea and use joins, and you can actually use subquery for exactly the same idea again. But it's not a type of join. They're two different things, but they can actually achieve the same purpose.
My second question, sorry. Is it because the joins we have gone through in details are those ones that have a common column, which is the predicate?
Yeah.
Is there any type of join that does not have a predicate?
No, they have to have a common column when you are joining what you are joining on. So if you are going to be doing like a cross join, you want to merge two tables together, you are merging tables on a common, they just have to have common columns to use joins. So that is the part where subquery will come in, where you can't use joins. The complexity you will encounter and the errors you will encounter when you try to do things that are not like the major purpose of that topic, right, is going to be too much, that it's better you look at each particular topic like subquery joins and see what they're actually really meant for, and don't go beyond the boundaries of what they're meant for, and use everything for what they are meant for. That way you reduce your errors, complexity, and unexpected behaviors.
Sorry. So does that mean that I can join two tables without a matching table using subquery?
Yes, with using subquery, you don't need to have a matching table. But see, that question is not straightforward. See, there are rules to this subquery, and I wanted to discuss that in advanced topic. You have to have select customer number. Yes, that's what you are selecting from here. Now, I say and customer number in select customer number. If I'm selecting something else that is not what I'm looking for here, I'm going to get an error. So it's not like you must have a matching column, but your query must be structured in a certain kind of way. And I'm going to discuss that in the advanced SQL topics in part 3. If I go into that now, you get yourself more confused. Yeah, so there's no straight answer to that question, but we are going to look at deeper examples to that.
All right, thank you.
Okay. So let's look at how to modify data, and let's look at the tables that we can use here. We have the customer table. We have too much columns here. I want to get a table with little columns that we can use. Okay, let's use the offices table. Let's try to insert a new office into this table. We have office 1 to 3, 1 to 7. We want to insert a new record here. Let's say we have a new office location. The syntax for insert statement in MySQL is to write insert into and then the name of the table. So let me just put table name. So insert into table name, and you put the name of the columns that the table has. Make sure that all the columns that are not null columns are specified, all the columns here. So insert into table name, all the columns, and then values and all the values. If you want to put several rows, as a comma separated list, you put all the values for each of the columns like this. So this is the syntax. Insert into table name, in a pair of parentheses, you list all the columns for the table. Then values, in a pair of parentheses, you list all the values for the columns, and then that's for one row. You put another pair of parentheses to list all the values for a second row if you want for multiple rows. So let's try this to insert into the offices table. So the query we are going to write is insert into, the name of the table is offices. So we insert into offices. The offices table has, let's even look at the columns properly. I'm going to go back there. We have the office code, the city, the phone, address line 1, address line 2, state, country, postal code, and territory. So let's go and insert that. Insert into offices. The column names are office code, we have city, we have phone, we have address line. It must be in the same order. The order of the columns must be in the same order as the values. It mustn't be in the same order as how it is on the database table, but once you specify the column name, the order of the values should be the same as the order of the column names. Okay, address line 2, then we have state, we have the country, we have the postal code, and then we have the territory, right? Now we want to specify the values that we want to be entered here. Now for the first value, office code, let's say 100, we want to put the city. Let's say this city is, I'll just use a city that it has to be quoted because it's a string. The phone number, let's quote this because it's a string. Then we want to have the address line 1. Let's say the address line 1 is, I'll say number 1, Success Street. And address line 2, let's say top floor. Let's look at the states to be null. Maybe there's no state. Let's say the country is St. Lucia. Let's say the postal code is LC01101. And let's say the territory is Americas. So we have insert into, this is the SQL keyword. The name of the table is offices. These are the column names in the offices table specified in the pair of parentheses. And then we use the keyword values and specify the value for each of this column here. I'm going to run this and we're going to see if all is well. So if all is well, one row inserted, I go to the table and I see that it has been inserted 100, grocery, everything I put here is here. If I come back here and I want to insert the same thing again, I am going to get an error. And I have an error duplicate entry for 100 primary key. If I want to avoid having errors and I'm not sure if something has been inserted before, I'll use insert ignore like this. And this will not produce any error, but will skip inserting that. It will just tell me 0 rows inserted and to tell me a warning duplicate key. So it does not halt my process. So in the event where you are inserting multiple records, you're creating your software at the back end, somebody is inserting something on the interface. You don't want the system to crash. You use insert ignore so that if they're entering something that is already duplicate, it will just send them a custom warning like the number one has already exists in the database or something like that. So this is why we use insert ignore. If you want to make sure that it fails gracefully, not crash the program, but just gives you a warning telling you that it did not insert this because it already exists. Now, if we want to do multiple values at once, let's say we've inserted this before, but we want to insert something else. Before the semicolon, we'll put a comma, another pair of parentheses, and then new values. Let me just copy these values here and make it faster, so we'll change it. So I'm going to copy it here. So I'm going to change this to 200. I'm going to change this to a different city. I'm going to change this to a different number. I'm going to change this to, let's say, Upper Street. I'll change this to first floor. Then the state, I'll leave it as null. The country the same. Postal code, I'll change to 100. Territory the same. Now I use insert ignore, which means it will insert the second one, but it will insert the first one because the first one already exists. And when I say go, you say one row inserted and warning for the first one duplicate key. When I go there, you will see that the second one has been inserted. The first one still stayed as it is. So this is basically how we insert new records into a database. Now we are doing this as raw SQL. When we get to part 2, when we begin to develop our software, we are going to be writing this from within Python, where you have a user interface where they fill forms, like you fill your registration form. The backend code is going to be inserting the values that you've entered into this form into the database table. And so these are the insert queries you are going to be writing embedded within the system later on. Okay, any question about inserting into the database? So for question?
No, I just felt like maybe when we practice this thing more, we look at it and we will now know, areas that are alien to our small brain. Then we will now develop questions for you in the next class.
Okay, that's nice. So let's say there was a mistake with this and we want to update the record. Let's say this 200, the city is not Castries, or just something is different. We can update a particular field, a particular column value for a particular record. We have to decide what is unique about that record. Is it the office code of that record is unique, or is the country that is unique? The country is not unique, so when you try to run an update, it's going to update everything that has that country name. Let's say territory is not unique. but we know that office code are primary keys, so they are unique by default. And so we're going to say we want to update this record. We want to change the city name from Castries to whatever city name we want, and we need to know which row we are changing. And so the unique code we want to use is the office code. So we want to say the update query is written like this. The syntax is update the name of the table, which is offices, set the name of the column we want to replace, which is city. So update offices, we'll set city is equal to, instead of Castries now, we'll say city is equal to, let's say, Rodney Bay. Where, so you must put a where clause to tell it which row of information you are updating. So we'll say where office code is equal to 200. We want to change the value of the city where the office code is 200. When I run this, one row affected, which means it's updated successfully. When I come here to browse, I will see that that city name has been changed from Castries to Rodney Bay. If I make the unfortunate mistake and I'm not using the office code as the clause, let's say, for instance, I say where country, for instance, is equal to let's say Saint Lucia. Okay, what is going to happen now is going to update everywhere where the country is Saint Lucia. That's not the intention. We wanted to update one row. When I say go, one row affected. When we come here, we have country Saint Lucia. It's updated both cities here as Rodney Bay. Why it has one row affected is because this was already Rodney Bay before, so it changed this one. If I decide to run that query again, and I say set city equal to, let's say city is equal to Vieux-Fort, where I'm not office code now, where territory is equal to Americas, is going to update all America. So these are the mistakes in updates you don't want to make. When you want to update and you want to update a single row, you have to look for a unique value for that row, which is usually the ID for the row or something like that. And when I do this, it's going to affect the two rows that has the territory Americas. And when we check those two rows, you see that both of their cities are changed. So when we use office code, which is unique, it changes just a row of information. If we use a particular column in the where clause, we say update offices, set city equal to whatever city we want, where territory is equal to Americas. Americas is not unique, so it's going to update all of the Americas territory with that information. So when you want to update, you want to be sure, do you want to update information for everybody that lives in a region, for everybody that has a particular criteria, or for a single person that has a particular unique code? So those are the things you need to bear in mind when you run updates. It can be disastrous if you don't understand that. Any questions about updates? Okay, so let's look at the last one. Now, let's say we want to delete both of the records we have inserted here. So now, because we want to delete both we inserted, Americas is common to both, you can come here to delete and we'll run the query. Delete from offices. Don't make the mistake of stopping here. You're going to wipe out the offices table. So delete from offices, you have to have a where clause where, if we want a single row deleted, we use the office code, what is unique to it. We want to delete both of the inserted, so let's use something that they both have. So let's say where territory is equal to Americas. And when I run this, I have two rows affected. I go back there and I have both of them deleted. from the table. Okay. So we're going to look at, by next week, after we look at how to create databases and tables, how to do more complex inserts using transactions. We have transactions in your pre-recorded video for this week, so I advise you to watch those lessons. Watch from week 1 back to our current week, so that when we get to week 5 next week, you will have more questions based on the past lessons to ask. And as we go ahead, we can go into more complex examples after you have understood the basic examples. Again, you can download more database samples from the MySQL website. There are different databases that they have to continue to run queries across different tables. I'll try to send you sample query or several example queries for you to try to run and see if you get the answer or understand the logic. That will help you and guide you. So any questions? This is where we end today's lessons. You have questions, you can ask now. Okay, in the absence of questions, I wish you a wonderful weekend. I am going to upload the recorded video once it becomes available by the end of today into tomorrow. Thank you and see you next week.
Thank you, Mildred.
Thank you.